Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the evolutionary process models in object-oriented software engineering. First one, business and the product requirements often changes as development proceeds, making a straight line path to an end product unrealistic. In such a cases, the iterative approaches need to be adapted. The evolutionary process model is also called as iterative process model. The evolutionary models are iterative. They are characterized in a manner that enables you to develop increasingly more complete version of the software. Prototyping. The software prototyping refers to the activity of creating the prototypes of the software application, that is incomplete version of the software program being developed. Next point, it is an activity that can occur in the software development and it is comparable to prototyping and known from the other field such as mechanical engineering or the manufacturing. Next one, when we chooses the prototype model, we have 3 points. First one, a customer defines a set of general objectives for software but does not identify the detailed requirements for functions and features. Second point will be the developer may be unsure of the efficiency of an algorithm, the adaptivity of the operating systems. Third point, when the requirements are the fuzzy. Although prototyping can be used as a stand-alone process model, it is more commonly used as a technique that can be implemented within the context of any one of the process model. The prototyping assists you and other stakeholders to be better understand what is to be built when the requirements are fuzzy. Next, the prototyping paradigm begins with the communication. You meet with the other stakeholders to define the overall objectives for the software, identify whatever requirements are known, and outline areas where the further definition is mandatory. And then a prototyping iteration is planned quickly and modeling occurs. A quick design focuses on the representation of those aspects of the software that will be visible to the end users. Example, human interface layout or the output display formats. Next, here we have the diagram for prototype model. First phase will be the quick plan and then modeling the quick design and then construction of the prototype and then deployment and the delivery feedback. The quick design leads to the construction of the prototype and the prototype is deployed and evaluated by the stakeholders who provide the feedback that is used to further refine requirements. And then iteration occurs as a prototype is tuned to satisfy the needs various stakeholders while at the same time enabling your better understand what needs to be done. Next one, ideally the prototype serves as a mechanism for identifying the software requirements, and then if a working prototype is to be built, you can make use of existing program formats or apply tools, example report generators and the window managers that enable the working program to be generated quickly. And then in most projects the first system build is barely usable, it may be too slow, too big, awkward in use, or all other three. There is no alternative but to start again. But smarter, build a redesigned version in which these problems are so on. And then the prototype can serve as the first system, the one that Brooks recommends you to throw away. But this may be idealized view. Although some prototypes are built as throwaways, others are the evolutionary in the sense of prototype slowly evolves in the actual systems. Next point, both the stakeholders and the software engineers like the prototyping paradigm. Users get the feel for the actual system and developers get to build something immediately. And then here we have the advantages of the prototype model. First one, users are actually involved in the development. Since in this methodology, the working model of the system is provided, the user get a better understanding of the system being developed. Error can be detected much earlier. Quicker user feedback is available leading to the better solutions. And then missing the functionality can be identified easily, and then confusing or difficult function can be identified. Requirement validation, quick implementation of an incomplete but the functional applications. We have the disadvantages. Stakeholders see what appears to be working version of the software, unaware that the prototype is held together, unaware that is in the rush to get working, you have not considered overall software quality or the long-term maintainability. And then usage of prototyping. Although problems can occur, prototype can be effective paradigm for the software engineering. It is then discarded and then actual software is engineered with an eye towards the quality. Thank you.